In a quiet lab at the University of British Columbia, a team of researchers may have just taken us one step closer to the future. A future where quantum computers around the world whisper to each other through light. The problem? Quantum computers speak in microwaves. But to send those messages across cities or continents, they need to travel as light through fiber optic cables. And that's where everything nearly falls apart. Microwave and optical signals are like two entirely different languages. Translating between them without ruining the message is a challenge that has haunted researchers for years. But now, there's hope, in the form of a silicon chip. Mohammed Khalifa, who led the research during his PhD, describes the breakthrough as a kind of universal translator. It's like finding a translator that gets nearly every word right, he says, keeps the message intact, and adds no background chatter. And it works both ways, microwave to optical, and back again, preserving the fragile quantum entanglement that makes quantum computing so powerful. That's no small feat. Entanglement, famously dubbed spooky action at a distance by Einstein, links particles in a way that defies classical logic. Break that link, and the quantum magic disappears. To prevent that, the team had to get creative with silicon. They engineered microscopic flaws, magnetic defects, into silicon wafers, the same material found in everyday computers. These tiny imperfections became the key. When carefully tuned, the electrons in those defects act like quiet, obedient messengers. They shift the signal from microwave to optical without losing energy or introducing noise. No drama. No signal loss. Just seamless translation. The entire device fits on a chip. It consumes only millionths of a watt, barely more than a whisper of power. Even more impressive, it can convert up to 95% of a quantum signal. That's an astonishing level of efficiency in the delicate world of quantum communication. This device could be the cornerstone of a quantum internet, says Dr. Joseph Salfi, the study's senior author. And while the work is still theoretical, the path forward is clearer than ever. Unlike exotic setups that require entirely new infrastructure, this solution works with existing chip fabrication methods. It can be built into our current systems with minimal disruption. And what lies at the end of that road? An internet immune to hacking. Navigation systems that work in tunnels and skyscrapers. The ability to simulate molecules, model climate, and solve problems beyond today's reach. No, we're not getting a quantum internet tomorrow. But for the first time, we can see how we might build one. And it starts with a silicon chip, and the quiet brilliance of a team that dared to speak the language of the future. Thanks for watching.